Okay, I think we can start. So welcome to my talk about, so we wait another few seconds. So welcome to my talk about Hadoop and the automated driving vehicle. In the next 30 minutes, I would like to show you how we are using Hadoop and its friends within our eHorizon project. And the dynamic eHorizon is Continentals' project approach for developing the automated driving vehicle. Do you know how many of your lifetime you're spending in traffic jams? Too much, right? Germans are spending around 300,000 hours a year in traffic jams. And to be honest, there are much funnier things than waiting or sitting in a traffic jam. A further challenge in today's mobility is efficiency. Did you know that your driving behavior is influencing the fuel consumption up to 20%? Another challenge is safety. 90% of all accidents are caused by human errors. And machines or advanced driving assistance systems may act faster and much more reliable than humans ever could do. So all these activities are summarized in the eHorizon project. And it's pretty obvious that the fully automated driving vehicle won't come overnight. It's a stepwise process. It already has started. Here you can see our Continental agenda till 2025. But it doesn't mean you have to wait till 2025. So there will be a lot of intermediary products which you can use on the road to 2025. The agenda already has started. So the features on the road to 2025 are from, for example, stop and go up to 30 to a speed of 30 miles, up to the fully automated driving vehicle on the motorway or on a highway. So on that road to 2025, there will be a lot of intermediary, very interesting intermediary products. For example, the cruise control or cruising chauffeur. That means you only have to accelerate and brake. You don't have to do the steering. Also, another very interesting feature is the intelligent traffic light assistant. That feature was presented by Continental on this year's Consumer Electronics Show in Las Vegas. The traffic light assistant informs the vehicle about the traffic light phases on your path. That means the traffic light assistant can inform the vehicle about the upcoming red phases, the green phases, and that knowledge can, for example, be used by the vehicle to recuperate, to recharge the batteries. That's important for hybrid or electric vehicles. And another feature is the hazard warning. And here too, I would like to show you a short video. So just one example for the dynamic eHorizon. All these activities regarding automated driving are summarized in the dynamic eHorizon project. So the dynamic eHorizon is, or the target of the dynamic eHorizon is to enable the car to look further ahead. So with normal car eyes, car sensors, you only have the ability to look further for about 200 to 300 meters. So by incorporating or by injecting further information, you enable the vehicle to look further ahead, to look around the next mountain, to look around the next curve. And one of the key components is the Continental backend platform. So in a nutshell, the eHorizon, the target of the eHorizon is to enable the vehicle to look further ahead. So before I go into details of our Continental backend platform, I would like to introduce the key players of the dynamic eHorizon. So on the one hand, there's an intelligent vehicle. And on the other hand, there's a back-end system. It means the vehicle must be intelligent enough to react on incoming information, must be intelligent enough to process the knowledge provided by the backend platform. The backend platform is responsible for aggregating or collecting information, new information sources, for example, information about the current weather, information about the traffic, map information, or also information detected by the vehicles itself. So let me show you some details about the platform. The platform is composed of three main components. The first one, the secure vehicle gateway, is responsible for doing the whole communication between the vehicle and the backend. And the counterpart to the secure vehicle gateway is the eHorizon Cloud Connector. And the Cloud Connector is located in the vehicle itself. It means taking data from the vehicle, sending the data to the vehicle gateway. And last but not least, and the most important thing, are the data services and map services. These services can be regarded as a kind of business logic. So that means the business logic, the black magic doing to aggregate or to generate some knowledge for the vehicles is done within these services. So before I go into further details, I would like to introduce an example, and that example, I will use that example to explain the further details. So it's pretty obvious that a very detailed, a very fresh map is essentially for the automated driving vehicle. So the vehicle has to know exactly where it is, what are the current road conditions, and so on. And such a fresh and precise map can't be created manually. It has to be done automatically. Oops. And this process, generating the map automatically, here too I would like to show you again a short video. So the key message of the video is that the vehicles itself are detecting the environment and providing that information to the backend. The backend can do some magic and provide the new knowledge back to the vehicles. So just a brief overview about the underlying system architecture. So we have here the vehicle. The vehicle is both it's information provider and the information consumer. Sends or communicates with the backend via the secure vehicle gateway. Secure vehicle gateway is doing the whole communication between the vehicle and the backend. And data and map services are doing business logic. So let me show you some details. I would like to focus on the data services, as we are here on a big data conference, and a lot of you guys will ask yourself, what is he talking about? What does it belong to big data? So relax, now the big data story starts. So here you see the kind of architectural view, a functional view of the data service component. The data is sent from the vehicle via the secure vehicle gateway to the data service component. And for example, which data is sent to the data services? In the vehicle, for example, uses its internal camera to detect traffic signs, for example. And afterwards, that information is sent to the backend system. So the data service component is composed of three main components. We have this one for ingesting data, the second one for storing data. Yes, we did it again. We created a data lake as well. And the third one, and the most important one, for processing the data, for doing the magic. So let me show you some details, some technical things. The data is sent using protocol buffers to the backend. In our ingesting component, we are using Storm and Kafka. Storm is used as a kind of connector between the gateway and the landing zone. The landing zone is implemented using Kafka. And our data lake is based on HDFS sequence files. Why HDFS sequence files? We used HDFS sequence files to avoid the small file problem. And within the data lake, all the raw data is stored. Storm is used to as a kind of connector between Kafka and HDFS. Spark is used for validating the raw data. Within the data processing component, we are using Spark to do the advanced analytics stuff. For example, to do the cluster and data fusion algorithms. For example, there's a dbScan algorithm implemented. And the results of the batch processing step are stored in an Amazon S3 bucket. And afterwards, the map component is informed or is notified using Kafka. So take care, now we have new results. And Kafka, the map service component, is getting the new results directly from the S3 storage or S3 bucket. Are there any questions to that architecture? Or? Yeah. We start here. So.
How long does it take from getting some information from the vehicle, round tripping it back to the vehicle, or the next vehicle?
In this case, we have to differentiate between batch processing and real-time processing. That part here is done in the batch mode. So the jobs are currently scheduled 2 times a day. So the jobs are running for a few minutes. So if you would do, I think your question targets if you would do it in real time.
Yeah. Like the example of a motorcycle,
yeah.
the car in front of him, realize the problem.
I don't know exactly the requirement. We have the requirement to ensure a complete request response time under now 0.3 seconds, I think. I'm not sure. So does it answer your question? So, sorry, there was...
how much data are you transferring from the vehicle gateway?
Well, it depends. So we started with internal Continental vehicles. So it depends on the amount of vehicles driving. So we have we had a requirement to ensure or other to say due to the lower bandwidth, we have to optimize that serialization formats. Therefore, we used protocol buffers. So it really depends. I don't have a number of so many megabytes, so many.
Okay, so you cannot say one machine is generating this amount of data on average.
So one protocol buffer message transferred from the vehicle to the vehicle gateway is about, I guess, I think less than 100 K. So it's one message.
Okay,
so and how many messages depend on the use case. So if you are sending, for example, only messages to the backend when you have detected relevant objects, it's less. If you are sending messages on a regular interval, then you have more. So it really depends.
Okay. And then,
sorry.
In the video, you were only you had in the top right. You probably had the backend view, what you detected, what objects and obstacles.
Right.
There were no vehicles. Are you filtering them out, or how do you doing? Are you doing a visual recognition of a vehicle? So because it is an obstacle at first, but it's moving. So
well, again, it depends on the use case. So for this example, we were focused on traffic signs or on speed limits, and all other obstacles and objects are filtered out. So, okay. So I just have to check my time because I have some more slides. So, but
I was just referring to his question, and I was wondering how you could deliver back the information to the vehicles. And I'm missing something like an elastic with special queries or so that you know the vehicle is in this and that position, and now it's a time to deliver the message that there might be slippery ground.
Okay, I got the point. That logic is realized within the vehicle gateway. It's a kind of geographical public subscribe. So it's security by design, therefore the vehicles are subscribing to specific geolocations, and then they are getting the relevant information. So, okay, we can do further questions afterwards. After that functional view, I would like to show you the execution view. So we are using a pretty normal Hadoop cluster. And it's a self-operated cluster, and we're using the infrastructure as a service approach. That means it's hosted in the cloud. So, and that brings me to my next point. We see some improvement potential within our current solution architecture. And we see the improvement potential regarding the fact that instead of operating your own Hadoop cluster, using a kind of platform as a service approach. So don't take it too literally. What I mean with platform as a service is just a higher level approach, a kind of managed service approach. For example, using Google or Amazon services. I come back to this just a few moments later. So instead of operating a standard Hadoop cluster, you could alternatively use managed services for all functional components. It means you could use a managed service for the batch computation. You could use a managed service for ingesting data. You could use managed services for storage. So before I go into the refined solution architecture, I would like to show you where we see improvement potential. First, regarding operations. So when you're using a more platform as a service style, a more managed approach, you can save resources regarding operations. So it's pretty obvious. You don't have to do a lot of operations because you're using the managed approach. So, and also, you don't have to take care about data security, data loss. So the backup strategy is offered by the appropriate managed service. The second point are costs. So by dynamically starting up and shutting down your cluster, you can save money as well. And a third point is flexibility. That means with that PAS approach, you're very flexible regarding cluster size and also regarding the software you are using. For example, part of your teams would like to use Spark version 1.52. The other ones would like to use Spark 1.6.2 or something. There is no 1.6.2. So now let's have a look at the refined solution architecture. You already have seen this one. So what did we do? First, we replaced our HDFS data lake-based storage, or HDFS-based data lake, by Amazon S3. And also, within the data processing, we replaced Spark by Amazon Elastic MapReduce-based Spark. So by doing that, we are enabled to dynamically shut up and shut down our cluster. That's an alternative for, especially for batch jobs. So if you would like to do further optimizations, you could also replace Kafka by Kinesis, Amazon Kinesis. So that brings me to a first summary. So our first experience are really promising. We could reuse our existing Spark jobs without modifications. And we had almost zero maintenance with the existing infrastructure. So when you are following that approach, you are getting a high flexibility, especially regarding the cluster size for batch jobs. So as it always is in life, you don't have to, but you can. It's an alternative solution. So it's my key message. I don't recommend to do a redesign of your complete big data architecture. it's well suited for a lot of scenarios, for example, batch scenarios. So you can, but you don't have to. And by following the PAS style, you are getting a high architectural flexibility. We will further analyze the opportunities. And that brings me to almost to my last point. I would like to end up with some lessons learned from our big data approach within our eHorizon project, lessons learned from our last year work. So the first point, take care of your metadata. So especially when you are creating a data lake, take care, maintain your metadata. So otherwise you are in danger of producing a data swamp and not a data lake. So maintain your metadata, take care of your metadata. So especially in the beginning, don't waste too much time in selecting the right distribution. Do it, start. So especially in the beginning, you are not aware of, or you do not know all requirements to do a serious selection. Then be aware there is no one-size-fits-all solution. Design your architecture for change. So your software, your architecture will grow with a Hadoop stack as well. So in this field, it is a very dynamic field. Tools come, tools go. It's very, very dynamic. So prepare your architecture to grow with the Hadoop stack. Try to automate as much as you can. A lot of the tasks you have to do more than one time. And the last point, that's a very, very important point. When you're starting your big data initiative, you need a very interdisciplinary team. You not only need a developer or a data scientist, you need a very, very interdisciplinary team consisting of developers, data scientists, maybe legal experts, and very important, you need domain experts. So therefore, due to the complexity, my recommendation, don't do it by yourself. Let's get in touch. So it would be a good final statement, but I have 2 more slides, just that you know who we are. The Continental backend team is a kind of pre-development research team. We are located in Germany and the US. So we have a very interdisciplinary team. And just a last sentence to Continental. So most of you will know Continental as a pure tires producer, but that's completely wrong. We are the 3rd biggest automotive supplier in the world, and we are also one of the biggest software companies in Germany. So thank you very much. Any further questions? Yeah.
Yeah, you generate a lot of data with your project. Is that data also available for other parties, or is it only for this project?
Third question, the third same answer. It depends. So, so in general, we are open for external customers. So it depends on the project. So there are ongoing efforts for integrating internal and external data. And there are also projects which are open only for internal customers or for our real customers. So it depends. But so if you are interested in doing a corporate project, we are open.
One question: what was the reason you decided to build up your cluster within the cloud and then to move at a later point in time then to a platform as a service? So there was somehow the decision first to build it up by your own in the cloud. Why have you then not done it completely on premise, for example? And then the second step.
So the refined architecture, which I have shown, is an ongoing activity. So we are evaluating it. So as I said, it's always a question of the use case, of the underlying use case. Batch jobs or batch processes are perfectly suited for doing it in a PAS style. But other use cases are not suited to do it in a PAS style. So when we started almost a year ago, and one of the targets, one of the targets was also to build up a lot of internal knowledge, internal competences regarding how to use Hadoop and all such things. So.
And what are the use cases you don't see as feasible for platform as a service?
Well, again, it depends. So, for example, if you don't have your data in the cloud, it's very, or it could be very in German aufwendig to bring it into the cloud. So it really depends on the use case. Or if you are doing real-time processing, I'm not sure if you should always use PAS style. Or some market isn't too big for PAS services, so you have to be aware if you are using Amazon service, for example, you are in danger of a vendor login. So it's not always technical issues. Any?
One question from my side. So is let's say the car also prepared in order to update, let's say, the data in the data lake? So for example, if something is on the street is no more in a good shape, and this must be transferred, this information, to the data lake, so that other cars can use this information too. Is this infrastructure also prepared for this or not?
Absolutely.
Yeah.
So that intelligence has to be built inside the car. So the vehicle agent I have shown. This part is responsible for detecting, for example, some holes in the street, and to transfer that information to the backend. So it's a modular designed application. So we are open for incorporating new kind of events. So.
Okay. Thank you.
You're welcome. No.
The use case of detecting the road conditions, which kind of data did you find most beneficial for you? Which sensors data are beneficial for the use case?
Especially for preparing the map data, all sensor information regarding your environment is useful. So things like danger on the street, traffic signs, dynamic speed limits, all such things.
Do you also use data from the vehicles, like from the vehicle network?
Yes, but not for a set use case. For example, we are using data from the powertrain to do a kind of long-term monitoring. So so the backend I have shown here is, I have to start again. The eHorizon is only one possible application of the backend. So also, for example, use cases like long-term monitoring could be done with that backend. So in that case, we use, we are collecting data from the powertrain, doing some preparation, some transformation, doing some geo-specific transformations, and generating some views. And these views are offered to the customer, and the customer is accessing that views directly. Okay. Okay. Thank you.